Hello everyone, I'm Xiansheng Math, and this is part 2 of data and variation in data. In part 1, we compared the ice cream prices of 5 stores in LA to 5 stores in New York. We saw that they had the same means, we saw that they had the same medians, and we saw that neither had a mode. So using mean, median, and mode, it's difficult to tell these prices apart. So what we're going to look at now is variation in data. We see two sets of data here that have the same mean, median, and modes, but what's different is their variation. And to look at their variation, we're going to look at what's called the mean absolute deviation. And how do we find this? Well, we find the mean of how far each of these values is from the mean, and that's the idea of absolute deviation. So I have 1, 2, 3, 4, 5 values. We're going to think about how far each one is from 8. It doesn't matter if it's less than 8 or greater than 8. That's the idea of it being the absolute deviation. Deviation is it being different from our mean of 8. Okay, so over here, our first value, 5, deviates from 8 by 3. So that's how far 5 is from 8. 7 is 1 away from 8. 8 is equal to 8, so it is 0 away from 8. 9 is 1 away from 8. And 11 is 1 away from, 11 is 3 away from 8. So these are the deviations from the mean, and now we're going to find the mean of these deviations. So we add up these 5 numbers. We have 4 plus 4 plus 0, so it's going to be 8, and we divide by how many there are, and there are 5. So we're going to have 8 over 5, which is 1 whole, and then 3/5 more to make 8/5. So we have the mean absolute deviation for this set is 1 3/5, or we could write that as 1 6/10. So here, the MAD is 1 3/5, or 1 6/10 as a decimal. Okay, and I encourage you to stop the video here and try to find the mean absolute deviation of the ice cream prices in New York before going on. Okay, we find it the same way. We consider how far is each value from the mean. Okay, that's its deviation from the mean, and it doesn't matter if we're less than 8 or greater than 8. So that's the idea of the absolute deviation. We're not considering positive or negative values. We're considering the distance each of these values is from the mean, which is 8. So 2, how far is 2 from 8? It's 6 away. How far is 3 from 8? It's 5 away. How far is 8 from 8? Well, they're equal, so they're 0 apart. How far is 12 from 8? It's 4 away. How far is 15 from 8? Well, it's 7 away. And now we need to find the mean of these deviations from the mean. And so we add these up. 6 and 4 are easy. That's 10. 5 and 7 is 12. So we have 10 and 12. And we're going to divide by how many values we have, which is 5. So we have 22 divided by 5. And if we have 22/5, we could make 4 wholes, and there would be 2/5 left over. So the mean absolute deviation over here is 4 2/5, or 4 4/10 as a decimal. So here we'll write, you can check your work to see if you came up with this on your own. So that's 4 2/5, which is equal to 4 4/10. So even though we saw these two data sets had the same mean, median, and mode, we see their mean absolute deviations are quite different. And that makes sense. We see none of the numbers are too far away from 8. The furthest value away from 8 was, in this set, was 3. So the average of the deviations was only 1 6/10. Here we had a value that was 7 away and we had a value that was 6 away. So here our mean average absolute deviation was 4 4/10. There's more variation in this set of data than there is in this set of data. Yes, on average you would expect to pay $8 in either city for an ice cream, but there's a chance that you're going to be spending a whole lot more or a whole lot less in New York, whereas most of the prices are going to be very close to 8 in LA. And that's the idea of variation in data. Hope you enjoyed the video and learned from it. Thank you for watching, and please press like and subscribe. It's Xiansheng.